Hello, I'm Manuel Castro. I'm professor of the Spanish University of Distance Education, the UNED, Universidad Nacional de Educación a Distancia, and together my colleagues from Spain, and CCP and Gaia, inside the ecovem project, the European Center of Vocational Excellence in Microelectronics, I will present the course delivery inside the ecovem project. We are finishing the project. We are in the last 4th year of the project, from November 23 to October 24. And we deployed all the 42 courses of the project. It's a real pleasure for me to present these courses. We have developed 42 courses. We are 11 of the project partners: Technical University of Sofia, SCAS, JARTEC, SEMI, EXO-Launch, EAL, FEB, INES Formation, and CCP, UNED, CPC, and ROMIT. The project in general, we have several presentations of the project, but in general we try to attract new people, new technical people to the microelectronics environment in Europe, and we develop a vocational training courses inside this project. This is one of the legs of the project. The other legs are the governance action plan of microelectronics in Europe, the business science education cooperation, the cooperation platform, and the events we are developing every month or every week, depending the time of the year. Final thing, BIT curricula, vocational training. We expect to develop 1,250 hours of BIT curriculum and have shown courses for 900 trainees in this last year of the project. The project is developed in work packages. The UNED is the leader of the work package 3, design of innovative vocational education training. And we developed these deliverables inside the work package, taking some of the documents from the work package 2, ecovem cooperation platform, the skills and occupation profiles for microelectronics in Europe, the plan for a new and innovative curricula, and we developed the new 5 documents: competence matrix for ecovem courses, the guidelines for innovative learning center, vocational education and training, instructional design for innovative learning methodologies, the ecovem curricula, and the teacher training seminars there. We are, as I told you, we are 11 partners inside the project: Technical University of Sofia, SCAS, as the Students' Computer Art Society, the JARTEC, the SEMI, EXO-Launch, EAL, FEB in Italy, INES in France, NCCP and UNED in Spain, CPC in Cyprus, and ROMIT together with the Technical University of Sofia in Bulgaria. Every one of the partners developed some courses. The partner that developed more courses are the Technical University of Sofia with 9 courses. The second one, we are in the UNED with 7 courses. Third one is ROMIT with 5. And we have several courses in the different partners. And we developed, in general, the major part of the courses in English, but we have some courses too in Bulgarian, in French, in Italian, and in Spanish too. The mode of delivery is different depending on the courses. The major part of the courses are online in standalone. Other small part of them are online tutored. Some of them are based for work-based training and on-site training. And some of them are too hybrid, on-site and online, depending on the courses there. Every course has its specific data sheet with all the information regarding it. Finally, we organized the courses in 7 different areas: design and manufacturing of PCB, printed circuit boards, microelectronics packaging technologies, integrated circuit designs, system design, fundamentals of microelectronics manufacturing, microelectronics for a greener economy, and key competencies and skills. The EQF we are developing is from 3 to 8, from the high vocational education and training to the number 8 is the PhD, the doctorate there. This is the same to BIT 2, 3, 4, bachelor, master, and PhD in the 6, 7, and 8 part of the EQF. We put the major part of the courses in ECTS or in ECBIT points, having in mind the hours of a student trying to work in there. The courses are oriented for initial BIT or for continuous BIT or for lifelong learning, training, retraining, uptraining, any kind of activities inside the vocational educational training. We develop the courses. We expect to have courses for minimum 1,250 hours, 20 courses, 40 modules, and we follow in general some part of the innovative learning support things. We work in performance support design, work-based learning approach, and task-based learning approach. And at the end, we have more than 5,000 hours of training. We expect to have 1,250, where more quadruple times the expected hours. In modules, we have more than 5 times of the modules. We have 227 modules, and we expect 40. And in courses, we have the double on 42 courses, and we expect to have 20. The courses have 2 sides. Some of them are based for online and hybrid courses. Others are for on-site courses. In this case, we have more or less the half of the time and the hours of the courses in online or in on-site, and depending the modules, we have much more modules and much more courses in online than in on-site activities there. Regarding the different areas or categories I put in there, we have the design and manufacture of PCB. This is category 1, and we have in this case 5 courses: PCB design, FPGA design, fabrication of silicon microsystems, basic of microelectronics manufacturing processes, and design and fabrication of PCB. In the second category is microelectronics packaging technologies. We have PCB design, microelectronics packaging, microelectronics for space applications, and basics of microelectronics manufacturing process. Regarding the number 3 category, fundamentals of microelectronics manufacturing, this is one of the more courses. We have 12 courses in this category: PCB design, fabrication of silicon microsystems, microelectronics packaging technologies, CMOS technology processes, training engineering for automotive electronics, semi-standards educational series, ultra pure water and liquid chemicals quality control webinar, voltage seg for manufacturing fabs overview, microelectronics for space application, bridge the gap photovoltaic systems, foundations in microelectronics, and basic of microelectronics manufacturing processes. Regarding the number 4 category, integrated circuit designs, we have 9 courses there: FPGA design, fabrication of silicon microsystems, design of ICs with cadence, circuit training with analog devices for alternating current and for direct current, and training on electronic circuit with analog devices, TCAD, task-oriented simulation with ORCAD PSPICE, foundation and simulation of FPGAs, and computer modeling and simulation in analog electronics. Regarding the number 5, that is the one that has more courses there, system design, we have in this case 16 courses: FPGA design, fabrication of silicon microsystems, design of ICs with cadence, embedded systems for automotive industries, C++ for automotive electronics, microelectronics for space applications, digital modeling and manufacturing technician, circuit training and analog devices, alternating current, direct current, training and electronics circuits with analog devices, task-oriented simulation with ORCAD PSPICE, bridge the gap photovoltaic systems, foundations and simulation of FPGAs, microprocessor systems, and computer modeling and simulation in analog electronics. Regarding number 6, microelectronics for greener economy, we try to be focused and to attract much more people to the greener electronics and to the greener economy, in this case in microelectronics. We have 11 courses in this case: principle of photovoltaics, cells and the different PV cells technology, manufacturing standard silicon photovoltaics, PV cells, fabrication, characterization and aging of photovoltaic modules, bridge the gap photovoltaic systems, smart industry and circular economy, foundation and simulation of FPGA, overview of biotechnology and microelectronics from the point of view of gender equality and people integration, automotive electronics, PV training and certification scheme for technicians, introduction to Internet of Things, and LoRaWAN technology. And the last one category, number 7, is key competences and transversal skills. We have an horizontal view of this kind of competences and skills needed for everyone in the new area of microelectronics and the new area of connected industry there. Entrepreneurship and validation of prior learning electronics, artificial intelligence and student career development, applied intercultural communication, presentation skills, pitching, project management, survival in the labor market, the entrepreneurial mindset of professional success, smart industry and circular economy, overview of biotechnology and microelectronics from the point of view of gender equality and people integration. This is cover all the 42 courses we have in the 7 different areas. Where to find this information? The best way to find the information is in the website we have in the project. First website is the ecovem.eu, is the main website of the project, where you can find all the news, all the information about the project, the objectives, the deliverables, the events, all the things we are developing. You will find it here in the ecovem.eu, and you have to, of course, a direct link to the course shell, as well as all the courses in the 7 areas. They have a menu where you can find any one of the courses you are looking for there. And of course, you can go directly to courses-ecovem.eu. As I told you, the courses are split in the 7 different areas there, in the 7 categories. And we have, in this case, all the 7 categories, all the 11 partners. And inside the shell, you can filter for the language, the EQF, the mode of delivery, the certification, the free course or the online or on-site courses, continuous or initial bet, and the EQF to have all this information available. And you can make a filtering to find the course. For example, in this case, we find one course. We are lucky to go there. In this case, we put as a filtering English, the integrated circuit design, and from the Technical University of Sofia. In the case, we have 2 different courses for this filtering. We have the FPGA design and fabrication, and the fabrication of silicon microsystems with piezo resistive feedback. And then you can go to our next step when you can see the inner view of this course with all the activities, all the objectives there, the data sheet we have with all the courses, the EQF, we are looking for these things, languages, course activities, and of course the link to go to the platform where you can find the course there. In this case, for example, you go to a different course, an overview of biotechnology, where you can find inside the course all the, in this case, a Moodle course. We will have different modules inside the course. Every module have the different information, some videos, some presentations, PowerPoints, some activities to have regarding there, some certification and evaluation and assessment of the activities there, and finally we have the certification of the course and the badges we have for each one of the modules there. For example, one of the courses of the repositories of the courses is the Unit 1. You have here the information of the URL, and you can register in this Moodle activities there. This is free. All of these courses, the major part of the courses inside the unit Moodle ecovem are free and open for all the people. You must register only in the platform, in the Moodle, and then you can select one of the 11 courses you have inside this activity there. Or, for example, in the Technical University of Sofia, Model Ecovem 2, you have the link there in the window, Moodle-TUS, ecovem.eu, where you can find all the courses from the Technical University of Sofia and the courses from the ROMIT in this case. And again, you have to register in the platform, and then you can choose any one of the courses, any one of the modules activities there. To finalize this part, I will make some time devoted to the courses. Each one of the courses, every course has a different duration, hours, modules, the categories we have inside it, the Moodle, and in this case the Moodle and the link of the Moodle. And in the case, the Technical University of Sofia courses, they have 9 courses in this case, PCB design, assembly and packaging, with all the modules we have inside it. You can do any one of the modules by standalone. You can do all the modules to have the final certificate of the full course, or only one module, or you can do inside each one of the modules only the tasks you like to do in this case. Every one is granularity, is depending. The one minimum is the task, module, and courses there. For example, in the first course, PCB design, assembly, and packaging, you have main assembling, PCB design principles, design of PCB with Proteus, with KiCad, with Altium Designer, fabrication of PCB and multi-layer boards, design of the package with SolidWorks, assembling of PCBs, and test of PCB. This is the the modules we have in this first course. Second course is regarding the FPGA design and fabrication. Third one is fabrication of silicon microsystems. You can see at the right, 180 hours is the first one, 150 hours second one, 120 the third one. Or for example, we have the fourth is microelectronics packaging technologies, wire bonding, multi-chip modules, single chip packages, stack packaging, and packaging levels and heat removal, 180 hours in this case, or design of IC with cadence. And in the case of the Technical University of Sofia, they have some courses devoted to have work-based training or on-site training in one of the industries you have. They have some courses developed with Melexis or with Bosch regarding the test engineering of automotive electronics, embedded system for automotive industry, or C++ for automotive electronics. And in this case are shorter courses developed and think regarding the work-based training there. And second provider is CAS. In this case, we have only two courses, entrepreneurship and validation of prior learning electronics, when you can see all the information regarding business ideas and selection of electronics subdomain, need analysis and market research, experience and information, important general competences, financial and legal basis and ICT skills, planning, quality management and risk management, renewable resources and energy saving, and validation of knowledge, skills and competences of prior learning on electronics. Or the second course from SCAS is artificial intelligence and student career development. This is a really actual and present activity and present course there regarding digital media literacy, labor market structure, how artificial intelligence structure the provider information, deep professions and new ones with focus on techniques and engineering, critical thinking, digital well-being, and career development and artificial intelligence during crises and pandemics. This is the two courses from SCAS, one course from JARTech, that is two key competences and transversal skills, applied intercultural communication, introduction, basic knowledge, cultural dimensions, communication styles, and business applications. In the semi-courses, they have three different small courses in this case, for 4 hours, half an hour, and 4 hours in this case. They are mainly oriented to the area of the standards that CIMI is really active on the standards activities there. Some of the two courses are located and stored in Vimeo. One course is located as a GoToWebinar, only in this case the third one. And they talk about semi-standards education series for E10 and E79, ultra-pure water and liquid chemicals quality control webinar, and voltage sag for manufacturing fabs overview there. Excellent courses, developed 4 different courses in this case. First one is oriented to microelectronics for space applications, introduction to microelectronics for space applications and satellite technologies, radiation effects and hardening of microelectronics for space applications, space sensor data processing, design and analysis of microelectronic circuits data transmission, fabrication and testing of microelectronic devices system design, and design, fabrication and testing. Or other 3 different courses regarding presentation skills, project management, and survival in the labor market that are mainly oriented to the horizontal and key competences for the people there. IEL, FBG from Italy, they developed 3 different courses, mainly oriented to be on-site, to be face-to-face activities there. First one is a short one, the entrepreneurial mindset for professional success, entrepreneurial mindset and leadership skills, that is developed for 12 hours in 2 modules. And the 2 last ones are digital modeling and manufacturing technician, digital maker, that is developed for a full year time for the people there on site in the IEL FPGA premises, with 1,056 hours each one of them. The first one regarding EQF3, regarding realization of 3-dimensional modules, programming machines, fabrication of electronic boards, firmware development, basic skills and supplementary and transversal competences. And the second one for EQF4, design of microcontroller devices and project specification, sensoric evaluation applied to the project, firmware development, prototype production, guide operation and 3D printing, basic skills and supplementary and transversal competences there. Ines in France developed 3 different courses mainly oriented to photovoltaics and all the area of principle of photovoltaics. The 3 courses are developed for on-site activities in the premises of Ines, and they developed the first one is principle of photovoltaics, PV cells and the different PV cell technologies regarding all the levels of the PV cells activities there for 14 hours. Manufacturing standard silicon photovoltaic cells, theory and technological responses for 21 hours, and fabrication, characterization, and aging of photovoltaic PV modules, theory and technological responses for 14 hours, in this case, the 3 in the premises of Ines in France. NCCP developed 3 different courses, mainly regarding to the electronics literacy of the people there. First one is oriented to analog device in direct current. Second one is analog device in alternate current. And the third one is the training in electronic circuits with analog devices, TCAD. UNED, my university, developed 7 different courses. Part of them are oriented to technical, part of them are oriented to skills and key competences. First one is task-oriented simulation with ORCAD PSpace, mainly for literacy and simulation of the people in the different areas of analog devices in microelectronics. Second one is oriented to the literacy in photovoltaic systems. Third one is oriented of the literacy in foundations on microelectronics, taking in this case some part of the activities in remote labs with VCIR and working in the remote activities for practical competences. Fourth one is smart industry and circular economy. That's really important today for all the people in any one of the sustainability activities for the world. Basic concepts of smart industry and circular economy, smart industry and technologies, smart and personal cities, circular economy relatives, and energy efficiency and circular economy. And the last 3 courses from UNED, this is the foundations and simulation of FPGAs for the literacy too in FPGAs activities and the simulation with Altera FPGAs. Overview of biotechnology and microelectronics from the point of view of gender equality and people integration. In this case, we talk about microelectronics, biotechnology, and green technologies, microelectronics digitalisation, microelectronics, gender equality and technology, artificial intelligence for microelectronics, and microelectronics integration of people. And the last course from UNED is regarding the basic of microelectronics manufacturing processes, where we make a really in-depth for 250 hours of learning of the students regarding all the manufacturing process of microelectronics. We have now the last 2 partners. First one is Cyprus Productivity Center courses. They developed 2 different courses oriented to the greener areas or greener activities electronics. Automotive electronics, advancing SUA systems control in microelectronics architecture, microelectronics for telematics control units, TQs, in vehicles. And the second one is PV training and certification scheme for technicians. Both of them are oriented to be on-site in the premises of the CPC in Cyprus. And the last 5 courses came from Romit in Bulgaria, and they have some technical and non-technical courses there too, design and fabrication of PCBs, microprocessor systems and computer modeling and simulation in analog electronics. And the last 2 ones are mainly oriented to Internet of Things or connected industry, introduction to Internet of Things, introduction IoT hardware, IoT wireless, IoT software and technology, IoT cloud platforms, projects in IoT, and IoT electrical energy meter as 2 part of the final projects there, because this is oriented to practical competences. And the last course of the 42 of the ecovem project is the LoRaWAN technology. That is one of the typical technologies used in sensoring inside the connected industry there. Well, we finished this presentation of the course. What to do now? Please go to the courses. First, read the important information in the microelectronics of the ecovem website in ecovem.eu. Filter the ecovem courses and the ecovem shell website, courses-ecovem.eu. Register in the ecovem partner repository course you like to do the task, modules, courses, and win the badges and certificates there, depending the level of activities you develop in the courses. And finally, repeat all this information regarding each one of the 42 different courses we have available for you to develop inside the ecovem project. Thank you very much for your attention. If you have any doubt, please send me an email. I can be available in any part of the website or in any part of the internet activities there. And it was a pleasure to present you all these courses that will be available during the last part of 2023 and all the 2024 activities of the ecovem project. Thank you.